top of the agenda. So let's go ahead and get started. This is Quic. It's working. Can you hear me in the back? Okay, cool. Thank you. Thank you, Andrew. This is Quic. If you're not here for Quic, you're in the wrong room. Let's go ahead and get started. This is the Note Well statement. Whether this is the first time you're seeing this or you've seen this on 100 different weeks in 100 different cities in the world, this is important because it's the intellectual property terms under which we participate here. So please do make sure you're familiar with it. You can find it by typing IETF Note Well into your favorite internet web search engine. Just as important, our participation here, we expect it to be professional and productive. If you have any problems with something that you feel is harassment or something like that, please feel free to talk to your chairs, Lars and myself, or if that's not comfortable for you, we have a team of special people who you can talk to, the Ombuds team. Sorry, Ombuds team. I will perennially mispronounce that word. Blue sheets I'll send around in just a second. We have a scribe. Thank you very much, Brian Trammell. You are a king amongst men. Jabber relays. Can anyone volunteer to relay what's happening in the room to Jabber and vice versa when necessary? Anyone? I see Patrick McManus thinking about it. You don't know? Oh, lucky you. Anyone, please? Thank you very much. Agenda bash. I'll get that. I'll do upcoming meetings in a second. Our agenda today, we're going to have a hackathon report from Ecker. Martin's going to talk about quick invariants. We're going to talk about a message that we had on the mailing list a little while ago about the working group's status and scope and our schedule. Then Martin will come back to give us an editor's update, and then finally we'll have a light and frothy discussion about the spin-bit evaluation design team from TED. Then tomorrow we're going to go in deep into loss recovery with Ian. John is going to talk about connection migration. We'll discuss what the third implementation draft is, and finally, if we have time, we'll get to some open issues. Any bashing on the agenda? Lovely. So real quick, this is our homepage. I'll make it bigger. There. This is. Can you see that in the back? Maybe. Okay. We have an upcoming interim. It's in Melbourne, Australia, in late January. You register online from the arrangements page here. There we go. Oh, yeah, I can see it down there. Thank you. And we have, I think, around 20 to 25 people registered right now. I wanted to bring this up because we're closing registration early because of the holidays. That closes on the 8th of December. So if you haven't decided, decide soon if you're coming. I'll also mention, as we have before, that hotels around there may be getting more expensive because it's during a major event. So if you haven't booked a hotel, you should get to that as soon as you possibly can. And just to give some people some visibility, we do anticipate meeting in London at the next IETF at IETF 101. And we've been starting to talk about an interim meeting after that. And right now we're penciling in probably early June or late May, early June in Europe somewhere. So that's still TBD, but that's our current thinking about the meeting schedule. Any questions? You're not coming up for a question, Bob, right? Okay, never mind. So let's go on. Hackathon and interop report. Ecker, do you want to talk briefly about what happened during the hackathon?
Yeah, so a pile of us got together, some physically, some virtually, to try to interop with draft 07. In classic form, we're already at draft 08, which has changed quite a bit, but we did 07. So this diagram shows what sort of worked and what didn't. Things that are in green are good. Things that are not in green are not as good. Things that are, this HDC code tells you kind of how much actually works. The good news is a lot of green. The bad news is HD and C don't actually cover that much of the specification. But still, it's a fair amount of progress, and it was, we're starting. I think we're starting to get in a rhythm of people being able to work with each other and get that stuff working. I guess the thing I would say that, so what these mean specifically is most people can handshake with each other, establish a data connection, and move some HTTP over it. HTTP 0.9 for those who were not paying attention. And sometimes we can get closed, though people are a little unclear on what exactly the test for closed works is under those circumstances. So I think the two gaps that I've been identifying, and I think other people perhaps have too, are in terms of like our readiness to test are, first of all, having clear standards for what success in any given test means. As I say, it's kind of obvious. I mean, it's obvious if you handshake successfully, but even that's not complete. And, is it one data channel? Is it 10 data channels? Is it big files? Is it small files? No one has answered those questions. Wow. What does closed mean? So I think as I think going into Melbourne, I would suggest that it would be good for us to try to recruit some volunteers who'd be willing to actually write down like relatively detailed what the test procedures these things are, so that we can actually know what success and failure means. The second gap is sort of a lack of clear continuous integration and continuous testing, and also automated interrupt testing. So there's a lot of, hey, can you make your server work so I can test against it? Where's your endpoint? Oh, your server seems to be down. I'm not going to send you a client initial and nobody answers. Is that because you're down, or is it because you didn't like my client initial? So we're slowly evolving some standards here. Lars and I had a conversation right before this meeting about trying to put together an actual framework that people could like fit into and test their own stuff and test other people's stuff. So maybe they can run on their machines, maybe they can run it in Docker, maybe they can run it in the cloud. It's not quite clear. Anybody who's interested in that effort and would like to volunteer some effort, please do. I imagine otherwise what will happen is we'll have something not very good together and you'll kind of be stuck with it or not. So anybody who'd like to spend some time on that, be appreciated.
Any questions? Further things people wanted to bring up about the hackathon or interop in general?
Like I said, a lot of green here, so this is pretty good news. The handshake, everybody's really got the handshake nailed, and most people have the data thing working. So that's actually a lot better than it used to be.
So a lot of green, which is nice. Thank you, Echo. Okay, let's move on then. Martin is going to talk for a little while about this concept we have been calling invariance. And I won't describe what it is because I don't want to steal any of his slides from him. If I can get it onto the screen. Yeah. Let's see.
Oh, that's kind of good. Yeah, I assume you all know who I am. Next. Right. So we've made something of an attempt in the draft at the moment to document the things that are quick. And I say quick in the generic sense, not quick in the sense of quick version 1 that we're defining that has HTTP running on it. I mean quick in the sense that is as much as possible immutable over time. We do really poorly at those sorts of things generally, and we find that they need a great deal of attention and effort in order to actually work over longer periods of time. But the goal here is to work out the things that won't change in future versions, the things that we're going to commit to. And so part of the point of this presentation is to simply see if the room agrees, particularly on the guiding principles that I've outlined here. And this is pretty simple, is can you negotiate the version of Quic that you want to talk with the other side? And in defense of that, making sure that middle boxes don't interfere with that to the extent that they need to do their jobs. And the primary function that we've identified for that being routing the packets to the right place. As long as the middle box can continue to route the packets to the right place, we are happy. If we do not provide something that's invariant, that will mean that the packet will need to, the middle box will need to know about the specific version of Quic that we're talking. We don't want that to happen because that will mean that we won't be able to deploy a new version of Quic because of the way that the endpoints in the middle boxes don't necessarily have alignment in terms of upgrade schedules and things like that. Currently, the idea is that anything that doesn't contribute towards these goals is subject to change. We could decide that we do want to randomize the initial packet number, or we could, in a given version, we could decide to do that, and we could all start using that version, and therefore you would not see a packet number of 0 or 1 ever at the start of a connection. We could decide to do any number of things as long as they fit within this framework.
So just so I clarifying question.
Yeah.
When you in version in this context, we're talking about Quic 1.0 versus Quic 2.0, not
Right.
version 5, version draft 0.5 versus draft 0.6.
Correct.
So,
Yes.
okay. So we're talking about
We can change anything up until the point that we ship Quic,
that's what I thought. Okay.
including these things. But I would like to get to the point where we have at least a reasonable level of agreement about the principles. And then hopefully, if we can agree on the principles, we can agree on the implementation of those principles, and we won't change our minds too often between now and the end of this process, because changing our minds on this particular aspect is painful. Very painful, particularly when people start talking about actually deploying the stuff that we're talking about building. There is a hope that certain people will put out reasonable sized experiments at reasonable scale with the versions of Quic that we're going to be defining prior to publication of RFCs. And if they're going to do that, they need to have at least some degree of certainty about these things. Does anyone want to comment on these things? I think this is probably a good point to pause and say, have I missed something major? Do I have this wrong? And Brian is going to say that I've got everything wrong.
No, this is pretty. Hi, Brian Trammell. Am I mic'd? Yeah, I am. This is pretty reasonable. I think this is the right. I think this is the right definition of invariance. I will note that there is a lot of stuff hiding behind B.
Correct. And
Do you
we're
have
going to
a slide
do
on
a
that?
little bit of digging on that.
Okay, cool. I will come back to the mic after we've dug.
Right. There's some digging to do. There's some more digging to be done later on. I'm going to try to carve out what digging we've done as opposed to what digging we will do as we go out. But yes.
Ian Sweat, Google. Yeah, this seems excellent, and thank you for writing this down. There's also a little bit behind A, particularly in terms of, in reality, there are going to be basically things are going to ossify-ish on the handshake packets in some way, and I don't know if there's anything we can do to prevent that, but I think the short form packets I think we can do something with, but the long form packets I think we're going to end up with some issues potentially, unless you have some clever solution to avoid that.
Yeah. So one of the things I wanted to do was get to the point that we agree on the principle, and then based on that, we can do some things to defend against the sorts of ossification that we have. You had some ideas, we floated them around. Those are reasonable ideas, and we can work within this framework on that, I hope. Cross my fingers. Yeah.
I'm just going to interject really quickly. It's a large echoey room, so if you're speaking, please make sure you're very close to the microphone, as I'm trying to do now.
So I'm Emil.
Get closer, Emil. Get very close to the mic and
Is it better
speak.
like that?
Yes.
Okay, good. So I am Emil. And is multipass part of B?
Come again. I'm
Multipass. Is it
Multipass.
part of A, B, or C?
So multipath is an interesting one. We haven't really talked a whole lot about what multipath might do to the wire image, but my expectation at least is that multipath is part of B to the extent that it needs to be part of B. And if that means that we need to do some talking about multipath in order to resolve this question, I'm not certain.
You are supposing that
But maybe we can
multipath
defer
is
that
the-
question.
That the routing will be independent of the version if you have multipass.
That would be the hope, yes. Yes.
Because if you have multipass, the routing is going to change. It's obvious.
Regarding the multipass issues, the people who have the draft on multipass are aware of that there might be ways with the current wire image how to do this. So I guess this could be solved in this way.
Please
For
get
Diesel.
closer to the
I
mic.
really can't hear up here. I'm sorry. It's
You
very
guys
difficult to hear.
really need to kiss the microphone while you're speaking.
The people who have the multipass quick draft are aware of alternative how to do it with the current wire image, with the current invariants.
Excellent.
Mike Bishop, Akamai. I will also point out that even though it may not be obvious that it's part of B, stateless reset is also packaged in here, whether that's B or it's a separate item. Because stateless reset implies you don't know the version.
So yes, stateless reset is an interesting one here. The current design more or less assumes that it is version dependent, but there are aspects of this invariant header that mean that it's not possible for that to be true. So we need to do a little bit of work around that, yes.
Sorry, I'm vertically challenged. Brett Jordan, I think this is the right level of abstraction for right now, given our current state. So I support that.
Ronnie Evan. So will this cause any more limitation on what you can do in future version in terms of the header?
Yes, absolutely. And that is why we need to get it almost right.
Because at the moment, the only thing, I mean, the version is the last place where we need to have supported in all versions, but that means that we cannot change the header and enlarge the header, do anything because if you want to do it this way.
No, that's not true. So the location of the version field is necessary for version negotiation.
Yeah.
But we can put other things in the header after that version
so
field.
how will it work with if to do it independent of the version? It means that you need also to be able to understand previous versions in order to structure previous headers structure.
So you need to, as long as the version negotiation aspect of the protocol continues to work across versions, once you've agreed upon a version, you can do whatever you please.
The question I was asking, do we require that if I support version N, I also have to support all version below them?
Oh, no, absolutely not.
So that will break here. Because I don't know what is, I mean, if let's say that currently the header stop at position 10, and now we make the header at position 12, and I only support this version that has only 12
I think the disconnect, is the word routing. I think Mark means routing towards an endpoint, means routing towards an endpoint, like in a data center. Well, I think you are talking about routing inside a network.
Yeah, I mean, if you understand it at all.
But that's not what Martin is talking about. Martin is talking about at a server farm, how do you consistently route to the same endpoint? Not in the network.
Okay, so if someone in the middle just route it, in the middle route it, there's no problem. It doesn't need to understand the message, just routing, not understanding.
Keep in mind that we do have IP addresses and UDP port numbers on these things, so
that makes sense.
Brian Trammell, I think that Lars's clarification is not a clarification. I think that it's a modification. I think that like routing of quick packets independent of version means where do the packets go, whether that's at a data center boundary or at some random point in the network. I think trying to say we only care about data center boundaries is an excellent way to break shit. And I think, I mean, we have, you know, the closer you get to the edge of the network, obviously, the more problematic this becomes. But this is what I mean by it. There's a lot of stuff hiding behind D.
Yeah, I don't think we need to necessarily rat hole on this particular choice of word. In fact, was that was. Yeah. All I wanted to say with this is, we need to make sure the packets, when they're sent, end up in the same place, or maybe not even the same place, the intended destination. Without any sort of possibility of ambiguity or version-dependent behavior. Now, there may be version-dependent behavior that's added on top of it, but we wouldn't be able to rely on that. That's all. Colin.
Hi, Colin Perkins. So what you just said, I absolutely agree with.
Yeah.
I think Lars's clarification did not clarify because he, if we are only considering routing to servers that happen to be, you know, in a data center or somewhere, then I think we have a problem.
Yes,
because I think peer-to-peer is something we need to consider and either rule in scope or explicitly rule out of scope. But we should have the discussion about that.
Yeah, let us put Lars' example as an example.
Jonathan Lennox. I mean, one thing. I mean, these are all inherently things that are outside the encryption, right? Anything inside the encryption is not an invariant.
Yes, I believe that is currently true.
So, I mean, I think it would have to be true because the things you're talking about here are all things that would not be part of the crypto anyway. So, I think that might make it easier to figure out if it's encrypted, it's not an invariant. So, don't even think about it.
Well, actually, the set of invariants that we have is actually considerably less than the set of things that are not protected by encryption. We don't make any promises about packet numbers, for instance, and we would continue to make no promises about packet numbers. Maybe we should move on.
Just Igor Lubashev, just to understand that by B, do you really what you mean is just that routing should be done by IP and UDP headers only?
No, absolutely not. The point is that it should be possible for someone to mark a packet using the bits that are version independent in a way that is consistent across versions that ends up in the intended destination. So if you're talking about using connection IDs, that's absolutely part of this. And connection ID is actually part of the invariants that are on the next slide. Can someone take me to that so that we can start talking about concrete things and not in the abstract?
So, do you guys have clarifying questions?
I was going to respond to that very briefly.
Quickly, sure.
The point here is if you use connection IDs for version 1, then you can continue using connection IDs for version 2, 3, 4, 5, 6. It's not to say that you can't use IP addresses and port numbers. It's not to say that you must use them. It's independent of that. That's what independence is, right?
I actually got up to talk about connection IDs because I don't think they're neither A nor B, strictly speaking, require them. Yet I peeked ahead and you have
closer
them.
to the mic.
So yet the connection IDs I don't think are required by either A nor B. Yet you have them, as I saw on your next slide. So I'm wondering if another guiding principle is at the risk of opening up this rat hole. What is another one of these invariants what we're going to allow, say, the NAT boxes or the middle boxes to see as an invariant and guarantee that will never change? And connection ID would fall in that.
That is essentially what we're saying here, yes. I mean, you
make
want
it
to split this
explicit.
down a little bit more, but it's I think we're angels on the head of the pin at this point.
Yeah, okay. Yeah, I'm not sure it is. You're looking at me funny, Mark.
No, I'm just looking.
I'm not sure it is just like angels on the head of a pin. I mean, there's as you said, there's routing in the data center and there's routing of people who you do not have a relationship with. And so for the purpose of routing the data center, the connection ID can move around between versions because you only accept versions you know, and you know how to find the connection ID by looking at the version number. For purposes of routing for like NAT boxes on the client's network, that is not the case. So I think it probably does need to be, it may be inconvenient to do a conditional lookup, but it's not impossible. So there's, I think the thing that is important to recognize is there are things which have to be which are required for cooperating people to be able to interact with each other, and the things required for non-cooperating people to interact with each other. And so I mean, A is only about cooperating people, and B apparently you think is about non-cooperating people as well.
That is a good thing to draw out. I don't actually know that we've properly explored that particular aspect of the question.
I mean, just to I saw Ian Twitch. So I mean, to be clear, it's always within scope in these discussions when someone proposes version 3 to say, that would be incredibly inconvenient for me, please don't do it. But that's different from the version negotiation, which basically is a practical matter. Once we agree on what version goes, it's going to almost impossible. It's going to get an enormous pain in the ass for everybody to change their version, right? I mean, you're going to be in hash fingerprints and shit like that, right? So I mean, that's what. So I think that it's important to distinguish between things that we think are basic principles of invariance and things that we just anticipate to be hard to change.
Yep.
So just to give folks some context, we asked Martin to give this presentation because we think it's important to start the conversation about documenting our invariants. We're not going to finish that conversation today, and it's great to hear some engagement on it, but let's get through Martin's slides and figure out what our next steps are as a group rather than trying to nail down exactly the principles and exactly what the invariants are today.
Yeah, I'm going to try to knock these out a little bit quicker now.
Okay, great.
Next. This is what we currently have in the document. We have a section that says these are the things that won't change between versions. And I believe this to be a fairly accurate translation of the principles that were described on the previous slide. It essentially says anything you need in order to do a version negotiation, anything you need to do to identify if the connection ID is present and where it is. And that is just about it. Nothing more, nothing less.
Ben Schwartz, MTU.
MTU. That is not guaranteed. And in fact, there's text on that, and the client initial has a size restriction, and in fact, that is how you identify a potential initial packet from a version that you don't understand. You use size. So there's some fudging around that, but we do not guarantee that the 1200 is actually an invariant.
Brian Trammell, the semantics of code points 1 through 5 in the long header type are also invariant.
I don't believe we've made that commitment.
Can you say that again?
We have not made that commitment.
Okay. That commitment will be made for you.
That was to Ian's point before, and we may do some things to make sure that those particular code points are not the only ones that people see in the particular circumstances that you're talking about.
That seems aspirational to me.
There's some fairly simple techniques you can use. But
so I definitely think like greasing, we can make sure the other code points are still usable. But I think to Brian's point, like we're going to be stuck with 1 through 5 unless like someone comes up with something like stupidly clever that I can't think of. And I'm not even sure it's worth trying to fix that problem. Anyway, but it's not a big deal.
We're not making a promise. I realize that the ossification problem happens and it exists, and things do sort of start relying on things that we inadvertently hand out.
I mean, I guess I'm actually surprised to hear people think that this is difficult. We just, we just make we make them all 0, and we stuff the actual value inside the encryption boundary, which was created like 2 weeks ago. So
yeah, that's not a terrible idea.
So I mean, like I'm the 5 things is difficult.
Yeah, you just put a random value in the front, and then
Anything
but version number.
We put breakpoints in the first few packets, or the breakpoints are going to be put in for us. If we put the breakpoints where we think they're going to be, then we know where they are. If we don't, then we're going to discover where they are.
Sure.
That seems to remain that remains aspirational as far as I'm concerned.
Jana Iyengar, I think the point of this is to say here are the things that we won't change. What you're talking about are the things that might get ossified.
Right.
There's a gap between those two
yes.
things. There's a pretty big gap between those two things. And I think it's important to recognize that this is simply saying across Quic versions, we will not change these things. There might be more things that we decide not to change in the future because they're inconvenient to any number of people. And that's fine. Right? This is the minimum set.
So just want to remind people, this is the second technical slide of the session, and we are half an hour into it. So it's a good conversation, but we do have an agenda.
Ronnie, Evan, just one comment. This is just the location, not the semantics of those fields.
Not the semantics, not the value.
The semantics can
nothing.
change.
In fact, we're not committing to sending the same connection ID on every packet from the same client. We're not committing to setting the packet number in monotonically
No, but
increasing.
you can rename the. Let's say you decide that instead of connection, you'll call it something else, and it will have different semantic. You can do that.
Different semantics are possible. Yes.
Right. And I would suggest it would simplify the discussion if we can constrain this to just what our intent is about what is invariant,
yes.
and the discussion of what goes inside of crypto and what gets greased is a separable discussion.
Right. Let's move on. That's right. I wanted to talk about this stuff. I did these slides a few weeks ago. So the big question that I think we've got here, well, there's two big questions that I think we need to discuss in this context. First one being, how does Quic sort of multiplex with other things? That has been raised as an issue, and I know that we closed this previously, but I think that was a bit preemptory. And the other one is, what other commitments might we make in light of the demands that middle boxes impose upon us? And we've got a later discussion on that, and I'm not going to talk about that now. If that work produces some things that we need to commit to in terms of this, then we'll add them, but I'm not going to talk about that right now. I will talk about the multiplexing stuff. Now, Colin, do you want to talk about that now? Because I've got a number of slides on the topic.
I'd actually like to talk about the formulation of the problem you have here.
Formulation of the problem. Okay.
No, Colin Perkins. Sorry, is this better? Yeah. So I think so I don't think this affects the later slides, but I think it affects the perhaps importance to which you put on the solution. I think that the characterization of this as how do we multiplex Quic and RTP is not, to me, the right way of looking at this. I think the problem that I have been trying to raise with this is how do we run Quic in a peer-to-peer manner, which means we then need to demultiplex stun. And if we can also demultiplex RTP and things like that, that's a bonus. But the key thing is stun, so we can run peer-to-peer.
Okay.
And characterizing it as how do we demultiplex RTP
yes.
is a different problem than how do we run peer-to-peer.
Right. And so stun may be easy, as Eka points out. But yes, that is a much better formulation than the one I had here. But the question that was raised was multiplexing, and I think that's a much better way of approaching it, which is saying, if we want to use Quic for things like peer-to-peer, which have a number of different existing solutions in place, how do we make sure that Quic fits in with the things that already exist there without causing too much disruption for those people?
Yes, we could run RTP within Quic. We cannot run stun and the peer-to-peer stuff within Quic. We have to do that at the level, at the exposed level. So
it would be seriously disruptive to put stun inside of Quic. I don't quite know how to do that. But
it would really quite increase our workload.
Right. All right. Next slide, please. Okay. So people want to use Quic for things like peer-to-peer. As a practical matter, that means multiplexing, or at least finding some way for these protocols to coexist. This is not really talking about using Quic for RTP, putting RTP on the inside as has been explored in a draft. This is really talking about the work that's actually Bernard did, and Peter, I think it was, in AVT Core. And one of the fundamental problems that we have here is that the multiplexing schemes that are in use today rely on having unique values for the first octet. Quic assumes that it has use of all of the values of the first octet. And so we have something of a tension there. Next. So, option number one, we make the observation that all of these protocols use crypto in one form or other. All of these packets are authenticated in some way. If that packet fails authentication for protocol 1, then try it with protocol 2. If it fails authentication with protocol 2, try it with protocol 3. This is possible. This shows that it's possible to multiplex authenticated protocols of any form, using any format, using any values in the first octet. It sucks. Next.
You have a question, hang on. Bernard, go ahead.
Bernard.
Well, my question was about option 2, not about this option 1, which I agree sucks. But
next, please. Let's get the question. The draft that Bernard wrote actually suggests that we change our invariance and we commit to providing the first 2 bits of the first octet as 1. And that would conveniently place Quic in the bucket that's currently unoccupied, the final quarter of the space. And then we could very easily identify Quic as distinct from SRTP and turn channels and DTLS and all of these other protocols that people run all together, apparently. I have some questions about that. If we do that, we commit to that now. We make an invariant And we make a promise that we're not going to use any of the other values on that first octet. And so this is why I think we need to discuss this, because this was one of the options that that draft put forward. And I think it would be responsible of us to actually engage with this particular suggestion and make a decision about it. Colin.
Hi, Colin Perkins. So that's one option.
Yes,
the other options are to pick some subset of these code points we wish to. You know, we could decide that we only wish to avoid collisions with stun, for example, or with ZRTP, or with whichever subset of this we feel like. So it doesn't necessarily have to be
right,
those two bits.
Yep. Something along that line would be fine. Yep.
Ronnie, Evan, what worries me with that is that we have 8 bits in the first byte. And I think we're already also talking about spin bit, and there are other uses for bits in this byte. So unless we have a 32 bits byte, then I don't think a byte is enough for the future in order to allow for each of these flags. So one option is to extend the first byte to 2 bytes. Maybe it will be better, but otherwise I see a problem with allocating 2 bits from those.
And I agree. This is one of the major drawbacks from this, is that we don't have that many bits, and we have been talking about using them in various ways. Eka's suggestion is actually an interesting one because it means that we don't have that problem. But we've been talking about using these bits in various ways, and giving away a very large portion of this space means that we have a lot less flexibility in how we approach it. That's the downside of this sort of approach. Spencer.
Spencer Dawkins is a curious individual, I think, at this point. What's your level of confidence that that's the set of protocols that you'd be asked to multiplex with Quic?
We had this discussion on the AVT core list, I think, recently. We have...
Good.
So the multiplexing scheme that's being used in peer-to-peer is generously a happy accident more than anything else. And it just so happened that the protocols tended not to collide. And some of the later ones that came along were actually engineered to fit within that scheme, specifically because of I talk about turn channels, and RTCP they've made some specific design decisions to keep on using this thing. But originally this was a happy accident. And I don't think that it represents a good architectural basis for these sorts of things to simply say, well, we continue to fit into increasingly narrow spaces within this first octet. I don't think that's a sustainable approach, particularly since we're already finding that the space is running down pretty hard.
If you've got an option 3, I'll sit down.
There's an option 3.
I also have Bernard in the queue. Let's do Bernard first.
Let's hear Bernard.
Yeah. Can I see option 3 and then I'll make my comment?
Yeah, so I would encourage you to do that. This is
my comment on option 2 is that aside from the problems it causes for the Quic header, it also allocates all of the remaining code points to Quic. So if you believe it's possible it could be something else needing a code point, then that's a problem from the RFC 7983 side as well.
Yeah, there's some tiny little slices left, but it basically makes the rest of the space unusable.
Right.
It's a huge slab, and we don't like it because there's not enough space for us, and I'm sure that anyone using this scheme would not like it because there just aren't that many slots left.
Can we rule out option 2?
I think we're moving on to option 3.
Okay.
I put the bad options first.
Guys, are these clarifying questions?
He wants to see 3.
Okay,
I want to see 3, and then I have an option about a comment about 2.
Okay.
But I don't want to waste our time.
So the other thing is, in the peer-to-peer case, you can spend that byte and take just one value, and then burn that, scrub that byte, throw it away, and then the rest of the packet is Quic. That's another option. Fairly similar to the last one. Uses less of the space, gives us control over the entire octet. The people in the peer-to-peer land, they spend 1 extra octet per Quic packet that's sent. Next slide, please. This is the more convoluted one that was in the draft, and this is another option. So the observation here is that long packets are only really used during the handshake, and during the handshake, you're not going to be doing SRTP necessarily. depending on whether you have, well, number of observations. Quic provides the same sort of services as DTLS. It has a TLS connection. It can be used for generating keys for SRTP. So you could define something like Quic SRTP rather than DTLS SRTP. Your need for DTLS is greatly diminished. And you end up with something like this, where you say that long packets are only used during the handshake. The long packets are the ones that are in that latter half. They never appear at the same time as RTP. So you can distinguish them temporally as opposed to by number. And the short packets collide with stun, but you don't see that many stun packets, and they're pretty easy to identify based on the magic cookie that's in the front of them, or the message integrity thing, or the fingerprint thing. There's like any number of ways. There's like 4 different ways that you can identify a stun packet as being unique, uniquely stun. Right, and there's only the first 4 of them, right? We could avoid those first 4 if it came down to that as well.
Yeah.
We just add 5 to our short header types, and problem solved. There's some various ways in which I don't think that's particularly ideal. Turn channels, I've got to admit, I really do not understand 7983 on that point, so we'll just call them collateral and move on. Next slide. Sorry? You think about where they're used, and I don't understand why you would need to demux them with Quic. So Quic SRTP for keying SRTP. You don't have any problem during the handshake for stun and Quic. You do have a problem between stun and the short packets for Quic if you're using stun for consent freshness. So you have to rely on one of the 500 ways in which stun packets uniquely identify themselves in order to distinguish them from Quic, or shove Quic aside. Short packets and SRTP don't collide, so once you actually have the handshake out of the way, there's no risk that those two would ever collide. And you have a demuxing scheme that is a little more complex than the existing one, but maybe not too awful. I have more slides, and I'm sure people are going to want to tell me that I'm terrible and I've got terrible ideas and I'm a bad person.
I was going to make another suggestion, but now that I've seen this is fine. We can do this.
Let's let Martin get through his slides, and then we can drain the queue. How's that?
Yeah.
I have another slide.
Real quick, there's a comment from Victor, which I don't, on Jabber, saying turn channels can only happen after you negotiate session via stun. They don't occur during the handshake. They are negotiated via full stun packets.
Correct.
Victor.
They're negotiated with turn servers. You don't exchange the Quic with the turn server, I would hope, but that's why the WTF. So the other option, and one that I kind of like, is, well, you define a new Quic version that has all the properties that you want, and problem solved. Maybe you could do the other thing. Maybe you could do something that's substantially similar to the sort of Quic that we're defining today, but a new version of Quic can do just about anything. And we're not making any commitments about the type fields in the first octet. So you can define type fields that are friendly to the peer-to-peer traffic that you actually want to exchange. And that's the last one I have. I think there might be another slide, but I don't know. Oh, yes. We can talk about this multiplexing thing for a little longer, I think, but should try to keep it tight.
So, yeah, there are, I guess, 2 discussions here. One is about the multiplexing, and the other is about the overall concept of invariance. And I want to make sure we don't lose the latter due to a deep discussion of the format.
So before we get back into the discussion on the multiplexing thing, the point of having the multiplexing discussion is to make the people who want to do this satisfied that they have enough options available to them, that the invariants that we have not backed them into a corner. Or we conclude that our invariants aren't necessarily generous enough, and we need to make some additional promises so that those use cases are properly handled. And so I would like to hear from people whether they think we need to commit to further things, or whether we can get by with what we have. Ian.
I was going to say, I think this is a great example of your invariance. From a personal perspective, I am happy enough saying we can do 4 for now and do 5 if we need to. But I think the example of 5 is an excellent example of why we can totally change everything with a version as long as it fits within the invariance. And it certainly gives us enough freedom to solve problems, including but not limited to this. If for some reason we came up with some foo protocol in the future that, like, for some reason just couldn't change its locations and we needed to interoperate with it. And I think the version bump gives us a heck of a lot of flexibility. So I think this is an excellent example, and yeah, let's do something of the nature of 4 and 5 from a personal perspective.
Yeah, and I point out that option 1 remains the safety net.
Please remember to be close to the mic.
Jana Iyengar, I just want to point to the chairs that the other Martin walked up
Closer.
Just, sorry? Oh, closer.
Yeah.
Jana Iyengar. I definitely think that I agree with you on the invariants. I think that the invariants are oh my God, I'm going to be kissing this mic.
No, but this is how we can actually hear you.
Yeah.
Sorry?
You need to be.
You need to be this
millimeters.
close so for us to hear you.
Okay, I'm sorry to the people behind me. So I think I think this is great. Thank you for putting this together, and I think the invariants I think they are the right invariants. I want to talk about the multiplexing option very briefly. So I'm going back to what Colin pointed out earlier, and in the context of something else, which is that you do not, as it is, have an exhaustive list of all the different conflicts we can have. Even with the list that you have generated there, that is not in practice the conflict that we will see on the wire. There are protocols that we haven't standardized here. Example, RTMFP. There are plenty of others that we will conflict with on byte 1, and we're going to have to deal with it when that happens. Because the list is not going to be exhaustive, and because we're going to look at every protocol and go, is this really used? My sense of, instead of trying to do an exhaustive match of which protocols we, or exhaustive match of all protocols and making sure that we don't conflict with them, it may be a more scalable approach to look at stun and go, or anything and go, is this something we want in draft 1, or is this something that we want to make sure that we avoid in draft in version 1? For instance, in this case, we can perhaps agree that stun is something we want to interoperate with. If we want to interoperate with RTP, not interoperate, if we want to share space with RTP, then we define something. And that something is either RTP inside of a shim, or Quic inside of RTP shim, or whatever it is. But we have a shim and we define it later. Because I think what we need to do really right now is simply define the one that we know that we want to coexist with. We can't exhaustively coexist with everything else.
Yeah, so I think the reason this is particularly important is that we have people actively looking at this particular set of protocols and its use with Quic. And I think that we'd be doing them a disservice by simply saying, sort it out for yourselves. So I want to make sure that we deal with this properly. But
I think it's the right thing to talk about it for sure. But that's my opinion would be that we look at that we work on trying to make the things invariant that we know we need to that we need to work with on byte 1, and the rest of them, the ones which we are not sure about, we leave it to the future.
So we're going to close the queue after Spencer, and after Magnus, we're going to take Martin and Bernard from remote land.
Hi, Colin Perkins. A couple of small points, and then I guess a follow-on to Jana's comment. So thinking of the shim, I believe that only works if it's either always there or it's greased. Otherwise, people will ossify around it not being present sometimes.
The question is whether or not the peer-to-peer use case sees similar sorts of. Yeah, you may be right in the ossification sense. Yes, given that Quic is going to look a lot like the peer-to-peer usage of Quic,
and peer-to-peer use of Quic and client-server use of Quic look the same from the point of view of the home firewall.
Right. Yes, and so that makes it very difficult for us. Yes.
Yes.
Yeah.
Yes. Option 4. I think picking a subset of things to avoid conflicts with probably makes sense. I'm not entirely convinced you can demultiplex these in quite the way you've specified. But yeah,
it's a straw man. Yeah,
yeah. I think that the key point is that we need to think about what we need to lock down to support the use cases we want for Quic. And as Jana says, we're never going to avoid all the other protocols. There's always going to be something that conflicts. And I very much think that the essential thing here is to enable peer-to-peer use of Quic, because I think we're going to want to do that. And since I really don't want to reinvent stun, I think that means we have to avoid the stun packets and specify very clearly, this is how you demultiplex Quic and stun. And if you're building a middle box that looks a Quic, make sure you understand these stun packet types as well and let it through.
I have a solution for that I'll share later. It's actually pretty elegant, so we'll see.
Yeah, I mean, the simple one may just be to say, well, we avoid packet type 0, avoid the 0 to 3 in the first octet.
We invert the connection ID bit. Think about it for a bit.
Yeah. But we need to clearly specify a simple way of demultiplexing them.
We need to move on a little bit since we are 10 minutes behind schedule right now.
Okay. Magnus Westlund. So I want to explain the turn channels, why they're there. Because in standardized usage, it's becoming that you run from one single base, including turn to the turn servers, which I mean basically is done to the turn server, and setting up the channels, and then you have it, or going directly towards the peers for the different options through other addresses, the peer candidates. That's why, but it's in sense you could actually run the turn tunneling, so to say, of the protocol across another source port from your local host. That would be a possibility, but it's not how it's been used. So that's why the turn channel is included in that table. So
okay.
Yeah.
I'm not sure that I understood about that, but I don't think it's particularly relevant to the question at hand. Do you have an opinion on the question at hand?
Let's take it offline.
So,
it seems like a detail.
Yeah, but I haven't strongly made up my mind myself if it's important or not for the touch channels, but I think stun basic is the most important here.
We can avoid stun if it comes to that.
Yeah.
Let's move on then.
Martin Duke. Martin Duke.
Martin Duke.
Yeah, the other Martin from F5 Networks. Just one clarifying question on for option 5. You mentioned that that we weren't locking in any of the bits in the flags byte, but I thought when you talked about invariance, we were actually going to take the con ID bit and maybe one other.
Yeah, so the first bit in the first octet is
the long form bit, yeah.
In the short form packet, we commit to the connection ID bit.
Yes, and we always commit to the long form bit.
Yes, that's right. So it's the 1.5 bits or what have you that we're actually committing to from that octet. Yes, we are committing to those.
And you can still work around that and with enough flexibility to make option 5 work.
We can do that. We can make some tweaks now that would make that even easier, perhaps for this particular use case. But yes.
Okay, thank you.
Okay, so next remote, and Harold, I'm so sorry, but the queues are closed. Thank you.
Is this is Bernard. Just a question about option 5. Is your proposal, Martin, to move the version field up?
No.
No. Okay, so
the version field could stay where it is. Unless we believe it would be necessary now to move the version field, we wouldn't be moving the version field.
Yeah, because in a number of protocols, the version field comes first because it allows you to change everything with a version. You basically look at that, and then you could, change the entire layout if you wanted to with a new version. But I gather here
that's still true here.
But the problem is you're kind of committed to certain aspects based on the long header and short header. But I guess my question was whether how much freedom you really have to move the version field around and say put it first.
Yeah, so we
you need the connection ID.
Whatever we do, the version field basically has to remain in the same place.
In the same place, right?
Whether, yeah, I mean, other protocols have chosen to put the version field right up front, but that's a choice that they make, and we've chosen differently in this case. But we're still basically.
It will break your routing based on connection ID, the one that you had in the first slide.
Well, exactly. To Ronnie's point here is that we have preferred to put the things that we use for things like routing right up front instead of things that are used relatively infrequently like the version. But we still have to commit to its position. Sorry?
Yeah, just...
only the long form package.
It will break the routing because it has to be version independent.
Anyway, I don't understand. Is there a particular point there, Bernard?
Well, it was just that you could essentially, if you were able to move a version field or connection ID or something else, you could combine that with a shim approach. Essentially, if you had the space to guarantee that an octet would have a given value, and the version field looked like the best candidate for that because you don't presumably don't require more than 16 bits of versions. If you had major and minor, so.
Yeah.
But if you can't move it, it's pointless.
Yeah, I think if we were going to do a shim type approach, we would have to do some fairly significant surgery in order to get everything working. Yes.
Ronnie Evan. My major concern is, again, like I said before, is with having just one byte, and how do we use it so we'll not take too much options from this byte to use as flags, because we at least use now 3 bits for the type, and I don't know how much we want to keep there in order to allow for that. So that's one limitation. And then if we use 3 or 4, if we use 4, for example, we still just have 4 bits, which there are maybe other usage that would like to, that will need something in the first byte in order to work, or something in that area. So either that, or we have to have, and that's why shim, it's okay, because basically it's 1 more byte that you can use. So I'm also okay with the solution that about using the just for stun, and again, that we need to verify that, but we need to be careful about our decision that we will not prevent that from using the too much limitation on the first byte.
I think I have what I need. I was going to point out here that it seems likely at this point that we will produce a document that exists standalone, that describes what Quic is in the invariant sense. It will be section 5.8 and not a lot more at this point. So I imagine a very short document. The idea being that we can then publish that document and commit to that document. And anyone who wants to, say, for instance, describe the wire image of Quic, they can point to that document rather than the more complex document that contains all of the details of a specific version of Quic.
Right.
And thank you, everyone, for your feedback. I think we have at least enough of a plan. I have a tweak that I might suggest, but other than that, we're good.
Right. Thank you, Martin. I just want to make sure people understand, the context here is that we're saying we want to write down the things that don't change between versions of Quic, that they are truly invariant, and that will drive discussions like what we grease and what's encrypted and not encrypted, as well as the discussions about what we expose to middle boxes and what guarantees they have that are version independent. And that's kind of the very high order bit here, and it's going to drive part of the next discussion we have about the scope of our work as well. So I thank you for that. I think that does that well. Is it controversial that we're taking this approach? Does anybody have concerns about this idea overall of documenting invariants? We had a little bit of a side discussion about one particular example that is driven by invariants, but I don't want to lose the higher order concern here. And Spencer's going to the mic.
Spencer Dawkins, this time I think is responsible ID. I wanted to thank Martin for doing this work, and I know it's not easy. I just had the observation that if you document the invariants in their own document, then you can open other documents for revision without having to have the argument about whether you're going to change the invariance too.
Yes.
It's easier to keep a document closed than a section, it seems like to me.
Yeah, that's a property I really like.
So I think it's a good idea to document the invariance. I think that the exact invariance in the table seem to still be, in fact, the principles from which the invariance derive and then the invariants themselves seem to still be kind of open issues. So I guess I'm hoping that this document will start with the principles and we can debate them, and then we can debate what derives out of those principles.
Okay, great. So we're going to talk about how to get such a document started. And I would expect that by the next interim, we'll have something meatier to discuss where we can really dig into the exact invariants and the principles behind them. So look forward to that, I guess. And that leads into another discussion. I very much wanted to have that discussion before we had this one. We sent an email to the list a little while ago that caused some discussion. In that, we've been doing this now for a year. We have a milestone in our agenda, in our charter, that says we're going to ship Quic to the IESG in March of 2018. That's a pretty aggressive schedule, but it's pretty clear we're not going to meet that right now. And so as chairs, Lars and I have been talking, and we've been talking to the editors and other folks in the working group about how we can make sure that we complete this work successfully. And the mechanism that we're proposing that we do that, that we adopt to do that, are a couple of things. One is that for version 1 of Quic, we focus only on our first use case, which is HTTP. And the second is that we adjust our milestones, and we focus on meeting those milestones. Patrick McManus very rightfully pointed out that the way we expressed that was not ideal. Thank you for doing that, Patrick. A lot of eyes looked at that before yours, and no one saw what you saw. But you're absolutely correct. This is as a group, we need to try to work towards agreeing on getting a V1 shipped, and that's what our focus is. We're proposing it be. And I wanted to have that invariance discussion first because I think it's critical for folks to understand that by focusing on just HTTP in version 1, we're not saying that Quic will only ever be version 1, or that other things, whether it's multipath or whatever, can't be accommodated by Quic. We need a strategy to make sure that Quic can adopt these things and meet these use cases in the future. And our strategy for that is largely around the invariance, that we document a few things that will not change, and everything else is potentially changeable, including our patterns of messages on the wire and lots of other things that aren't covered by the invariance. And so this is the proposal of our scope for the immediate future, where we will be focusing on the HTTP use case, and other concerns we're going to park until we're working on V2. That doesn't mean people can't work on things in parallel, but as a working group, our focus will be on shipping that V1 for the foreseeable future. I think the proposal is November of 2018 is when we're going to try and put a pin in and ship V1. This was discussed on list, and I think with Patrick's positioning, it seems like there's pretty strong consensus in the list that this is a good direction to go in. But we wanted to have an explicit discussion about this here in the room and make sure that people understand and that we understand the implications of that. So, please.
Hi, Colin Perkins. So, by only focusing
a little closer to the mic, please.
Oh, sorry, Colin.
It's absurd how close you have to get to the mic.
It is really absurdly close. I'm not sure I want to get this close to Jana's.
Bring tissues to the microphone line and just
right. Wet wipes or something. Yeah. So, but by only focusing on a client-server protocol like HTTP, we run the risk that we will never be able to run this peer-to-peer, because unless, I mean, it harks back to the invariance discussion, but unless we can run stun or something equivalent to it, in the first version, we are never going to, because it will ossify.
And that's exactly why we had that as part of the invariance discussion, is there's a realization we need to do that.
Yes, but I think there's a realization that this cannot just be HTTP. We need to explicitly say we're going to enable, for example, peer-to-peer.
It's the invariance and HTTP is version 1. Right. And the question is whether the demultiplexing with something like stun is part of that. And my personal feeling after this discussion on the list is that so nobody has said that's a stupid idea, we shouldn't do it, right? So it seems like this is something implicitly seems to be consensus for. But if we do it, it needs to be part of V1 because it will be part of the invariance.
Yes.
And it's the distinction is that it's not that we can ignore the rest of the world and only focus on HTTP, and perhaps I misspoke there. It's that we're not going to fully flesh out every capability of Quic in V1. It's that we're going to make sure that we can cover what we need to cover in the invariance, so that in the future we can have a good chance of being able to do whatever we need to be able to do without changing those invariants.
Yes, I agree. If we say we are only focusing on HTTP and then we're building invariants, we run the risk that we build invariants that only work for HTTP. And that's my concern.
Ted Hardy speaking. I think I can stand further back because I'm louder, which is probably handier.
You need to be more loud.
More loud then.
Okay.
Seriously.
I can be even louder than that, trust me. So I also had some agita with the idea of doing this HTTP only for version 1 for many of the same reasons that Colin just elucidated. But I really liked your second formulation a lot better, which is we're going to build V1 with a set of invariants. And what we're going to deliver in the time frame that's currently being proposed is HTTP and a Quic which obeys those invariants. You don't have to then say whether or not the Quic which obeys those invariants and is delivered for the use case of HTTP is only for HTTP or not. Somebody, and I'm thinking of Christian's work on the DNS or some of the other work that's going on with people experimenting with running their protocol over Quic, can go on in parallel and provide input onto whether or not those are the correct invariants or not as you go. So I think if you drop the for HTTP only and say using these invariants and delivering HTTP, I'm totally on board. But if you say for HTTP only, I believe that will be a stick to rule things out that the invariants would have kept alive. So I hope that that's considered a friendly amendment.
Yeah, thank you for that. So one thing we didn't explicitly say, although I think it might have been in the email, so the reason why we're sort of saying that we want to focus the work around Quic for HTTP for version 1 is that the editors and the chairs believe that we've had discussions that took quite a bit of time, especially at the interims, that weren't furthering that goal, and we have to push back 6 months, which has caused some grumbling by implementers, and going much beyond that, I think, will cause significantly more grumbling. So moving the milestone is a big deal for some people, and we recognize that. And we hope that by focusing the next 6 months or so of work, we can actually confidently ship something that people can run. That as Ted just tried to summarize, that isn't to say that people should stop looking at multipath or stop looking at partial reliability, because we will want to know that the Quic with the invariance that supports version 1 that we deliver makes it easy to add other things in the future. Except, we cannot fully architecturally do multipath and other things while we're at the same time still waiting to do V1. Right? So the idea is that we prioritize HTTP because it's the most well understood use case for Quic at the moment, and we make sure as we can that we're greasing the hell out of everything else so that further extensions become easy and remain possible.
Sorry, I'll add just one thing to that. I think it's important to keep in mind the invariants are intentionally quite broad. There's so much of what's happening is inside of the crypto and is outside of the invariants that, and sorry, not broad, they're quite limited. So, there are many things we can do without violating the invariants. And I think it's important to appreciate that. Go ahead.
Ronnie Evan. I listened to what Lars now said, and I think that the issue, I don't think it's invariant. It's because the first issue is that doesn't address the needs of HTTP over Quic, but there's no document that says what are the needs of HTTP over Quic. There are assumptions what are the needs of HTTP Quic. So I think together with the first bullet that says which are realistically achievable in this time frame is the point for that, because a lot of things that are being discussed are also relevant to HTTP over Quic, like multipass has some relevance to that, but you can say it's not realistic, okay? But just to say that it doesn't address the needs, unless you have something that says what are the needs.
I disagree that multipath is required for HTTP over Quic. It would be nice to have for sure, right? But it's not required.
So no, it's not required. It's not realistic. I don't think it's not required. I mean, again, is there a document that says what is required for HTTP over Quic? I didn't see such a document. No, but that doesn't say what is the requirement. That says what you want to do there. No. So I think that we, at least I think that we have to see what is realistic to have in version 1, and by that to work and see that it's applicable also for HTTP over Quic. For example, in my case, I have the manageability issues that I think it's realistic, and I mean you can say it's relevant because otherwise you have problem with managing network that runs Quic over anything over Quic.
Ian Sweat, Google. That is an interesting point about multipath. For example, we've decided that doing HTTP header compression of some sort is a requirement of some sort for HTTP over Quic. But I mean, we could do HTTP 1.1 over Quic and like ship that, and that would be very easy and it would totally work. But so I mean, I think that's an excellent example. I don't know if we need to write down what the requirements are, but I do think that there is an implicit set of requirements that the group or some people in the group have, and at some point we're going to have to decide what's the boundary there. But I don't know.
Yeah, fair point. I think there's an implicit assumption that when we said HTTP, we meant H2 like HTTP.
And in fact, it's in our charter.
Okay. My actual comment was obviously like modulo, all the feedback from Patrick, which was excellent feedback, which I didn't see the first time when I said this looks great. This is awesome. In terms of exact time frame from my editor hat perspective, I feel like if we don't have something that we think is pretty darn implementable by London, that like we're in bad shape, like really bad shape. Because I don't know about everyone else, but like most, it's going to take a non-zero amount of time to finish implementing whatever people haven't implemented in Quic, and then it's going to take, even if you have a pretty strong infrastructure, probably like another 4 weeks to like ramp that up to like be global. Maybe it's 2 if you're like Facebook and you're super, super fast. And actually getting large scale deployment and then fixing all the bugs that you find and so on and so forth. We need to give people like 5 or 6 months, I would say. So I'm saying, I don't know if everyone else agrees to this, but yeah, I say London, and if that should be really a hard and fast goal. And at that point, if we can't get something done, we should start like cutting things pretty ruthlessly.
Let me quickly interject as a Jabber comment from Lucas asking when a revised milestone plan is likely to come out. And I guess this is for Mark and me, and I'm guessing pretty soon after we have had this discussion, we're going to send an email.
We'll talk to Spencer and then fulfill that. Yeah.
Pat McManus. So, I think the original sort of problem may be a one-time only problem here. The charter was written and it said a couple almost implicitly conflicting things. It gave a fairly short timeline to submit the original document, and it also said, everything in the document we're adopting does not have consensus and has to be revalidated. And I just think those things were incompatible. The good news is, as we move along, there's less and less in the document that doesn't have consensus, right? We're working through those issues, and I think that's sort of what we've seen going on. So, I think that's good news for us going forward if we just work at a slightly quicker cadence. I don't think we're going in circles, which would really, really concern me. I just think this is a matter that the original layout was more aspirational than realistic. I will put on my HTTP hat, and I will say that I think the header compression is actually a requirement to make this protocol work correctly for that use case.
Jana Iyengar. I want to simply echo at least echo some of the points that.
Echo louder.
Sorry. I feel very weird.
Get close and speak softly, or step back and speak loudly. Those are or both.
Yeah, clearly. I'm going to try. So I think this is very useful to have. I think it's very important to have this direction right now. Personally, for me, I've heard a number of implementers talk about how once work is started on implementation, you can't pause and wait for things to change. So it's important to allow implementers to go forward and finish implementing and deploying it as well. I think Ian's exactly right that we need to allow for a while for folks to finish implementing and deploying. I think 4 weeks is very optimistic. People need months to deploy and try and see what happens. There's another bit of urgency here that I want to raise, and this is ossification that's happening already. This is why I think the invariance discussion is very timely, and it's important to have now. If we not only can agree on the invariance, but we can also allow for us to move on the invariance quickly and agree on them as quickly as we possibly can, meaning not just do we agree on the fact that these are invariants, but we also agree on where those invariants appear in the packet. This will allow us to implement and deploy these things faster and prevent ossification of anything that's going to need changing as we go through this. I guess what I'm trying to say is that the invariants, while we are saying that we want to allow for these to change up until we declare we want done, I'm saying that in reality, we may want to do that sooner.
Yes, I mean they need to be done at least when we want to ship V1, but they don't have to wait, and they shouldn't wait for that. So I think the invariants are probably the most important thing that we can spend time on after this meeting or during this meeting. Praveen.
So I had 2 comments here. So I overall agree with this, direction. One of the things I wanted to say was HTTP over Quic is very general. So it might be useful to, maybe define an API, which kind of, V1 API, which would limit the amount of functionality we would ship in V1. It would be pretty useful to define what that is. The other thing I would say is instead of, yes, we are saying December 2018, but it would be nice to work backwards from that and have actually milestones and deadlines on the mailing list. For example, invariants, we lock it down by, date X. And if people have use cases that they want to try out and want to give feedback to, expand the set of invariants, then they should do that by a certain date. And if you're after that, then, hard luck. So I would like us to put more deadlines versus just December 2018.
So, I mean, with Ian's goal of having something pretty stable by London, that basically means we have the invariance lockdown in Melbourne, which I see nodding. Do we think it's doable? Yes. Okay. So I guess
maybe.
That's.
I hope so.
Okay.
Brian Trammell, just going to throw a little bit of oil on that fire, not very much. I agree very much with Ian's point that we need to get. I would say that if we go into Melbourne and it's not just cleaning up a little bit, then we have a problem, right? If we have a discussion that starts like this in Melbourne, then we have a problem. If we work before then and get down on it, then I think we're good. I also agree very much with something that Jana said, but I forget what it was, so let's just say all of it. I think that we need to be, with respect to really emphasizing these invariants, I also agree that sort of the shape of where we want them to be right now is probably correct. I'm not sure how to document the split between invariants of the contract that we'd like to make and the contract that is going to be made on us, right? So that the externalities. I think those externalities need to be documented somewhere. I don't think that we need to document them on the, we need to know where they are on the front end, but we don't want to basically put them in the document and say we already concede this point. And I'm not really sure how to do that. Maybe one of them goes into the invariance document, one goes into the manageability document. I'm not sure where to put that split, but that's something that I think we need to pay attention to as we drive forward to that.
I agree. We need to be aware of it, certainly.
Yeah. So
I think descoping is good, and having, I mean, you know, when stuff projects are late, you can add more manpower or descope, and maybe both. And you know, moving to more rational dates is good. I mean, obviously, March is now beyond science fiction and into fantasy. I guess the caution I want to say is, like, you can write whatever shit you want on like the milestones, right? But like, what makes those dates work is people actually work on things. And so, I mean, when I hear people get up and say we should be working faster, what they're really saying is I intend to work harder. You know, so I mean, that'd be great. I work pretty hard. I could probably work harder. But I mean, you know, the problem isn't that the milestones aren't aggressive enough. The problem is like people are not working fast enough. And so, you know, so it's going to take, you know, I mean, when you say that, what you're saying is I intend to, like, you know, I intend to work harder. I intend to be more willing to compromise. I mean, I intend to do things that make the thing move faster, right? Right. So, I guess that's, so I just, like, I'm not pointing fingers at anybody. I'm surely as bad as maybe some people, maybe all. But you know, I just want to, like, when you're saying those words, remember those things next time we come to talk about something that's like difficult.
I share your skepticism about, you know, just because we set the date doesn't mean we're going to meet it. And it makes me wonder if we need to reconsider our schedule for meetings, if holding more interim meetings is, we've talked about in the past, and we've decided that that was too much of a commitment for a lot of people. Do we need to revisit that decision if we want to make an aggressive schedule?
And I think about that a little more, but I mean, I guess my initial reaction would be, I don't think more interim meetings is going to help. The problem is interim meetings are not so large. They're practically working. They'd be a working group meeting for many other working groups. I think what will help perhaps is, you know, I mean, I hasten to point out this is not like the way the IETF typically plays the game, but you know, mini summits of people who like are the major people who are like having trouble coming to consensus on things. Those guys should be meeting themselves and trying to resolve them. And I've seen that work on other places. That worked on RTC Web pretty well. So I mean, obviously it was going to be vetted in the room in the working group and all those things. But like, if what happens is, you know, that Martin Thompson and I can't agree on something, and we wait until Melbourne to fight it out, and then everybody else in the room sits there and watch us fight it out. That's like not going to help. That's not helpful.
Right. I also observed that the implementers seem to make a lot of progress when they're at the hackathons or the interop events and right before them. And maybe we need to increase that pace.
Yeah, I think perhaps it might be useful to have an extra hackathon. I think one that happens that we found, I think more perhaps with TLS than within Quic, just because Quic, I think we're just all struggling to get anything to work at all, is that people in the people in the hackathons were sort of very willing to sort of provisionally compromise on something just to get it to work at all, and then, you know, and then after that was done, people were like, well, you know, it's not so bad, or, you know, or no, it really sucked, or whatever, and that helped make progress too.
Mike Bishop, Akamai. So I will, on the question of more interims, in person, I will say, please God, no. However, I will observe that there's this wonderful thing called the internet. And a lot of our interop testing and hackathon, we could do virtually by way of Slack or schedule a conference call or a WebEx or whatever. And if we need a more frequent meeting of a part of the working group or the entire working group or an interop test, go for it.
Maybe one day a month of interop or something like that. Yeah.
I mean, between now or between the last IETF and this, it has been noticeably more active on the Slack channel in between, right? So people are basically have public servers up, and other people say, hey, I send you a client hello, can you tell me what happened on your side on the Slack channel? So that actually works, but having a formal sort of joint time where everybody's on Slack, I think would be very well. I was going to say something else, I forgot. Okay.
Do we want to put the editors?
Yeah, I already did that.
Okay.
Yeah,
Oh, okay.
So I think we've heard from a bunch of folks on that, both here and on the list. Lars and I will go and chat with Spencer, and we'll figure out how best to reflect what we understand the path forward is going to be. I'm not sure what form that'll take yet, but we'll figure it out. We're going to do a slight agenda modification. We had the editor's update up next from Martin, but we're going to shift that till tomorrow so that Ted has time to talk about the SpinBit evaluation design team. Ted. Yeah, yep, sorry.
You can stretch now.
I can stretch. I can see there are at least 8 people who recognize the Konami code.
A little closer. Ted, a little closer.
You can't hear you.
Okay, I can see that there are at least 8 people who recognize the Konami code. Thank you. SpinBit round trip time evaluation team report. Take 1. Threat model, geolocation. As you remember from the discussion at our last non-interim meeting, one of the potential threat models that we discussed was that somebody would be able to take this round trip time information and use it to determine the geolocation of one of the endpoints. The design team considered that pretty carefully, and it has consensus that the use of the SpinBit is not a significant new source of geolocation information. The reasons are up here, but they boil down to this. 1, there's a lot of this information already out there, and therefore this is probably something commercially available to you if you really cared. 2, the data that you get from this turns out to be very, very coarse, and there's a nice thing in the links at the back of the slide from Brian, which demonstrates just exactly how coarse. And lastly, it turns out that for a lot of this, tracking the handshake round-trip times for related IPs, that is an IP prefix rather than a single IP, would give you very similar min RTT data. And it's important to remember that minimum round-trip time data is the critical thing for geolocation because it's the best possible reflection of where something is. So, next question. The next question to the design team was, well, what about things that aren't just min RTT, where what you're trying to do is to see the pattern of round-trip times throughout the course of a flow. And DKG and Christian Wiedema pointed out during the interim meeting that actually there's a problem here. And that is whenever you don't have consistent exchanges between the peers, that is whenever there's sparse traffic, you actually get the wrong data because you get the application latency instead of the round-trip time. So here's an example in beautiful ASCII art translated into non-ASCII art, where you have a quick initiator talking to a quick responder. It sends across a piece of work. You get an acknowledgement of the piece of work. Theory states that at this point, the quick initiator has kind of mentally changed the spin bit from up to down, but because we don't ACK-ACKs, there's nothing on the wire to show you that that mental change has occurred. Instead, the next thing you see is in fact another thing from the quick responder to the quick initiator when the work's complete. That gets acknowledged, and that's when your spin bit changes, which means all the time between the request acknowledgement and the work being complete is not visible to the wire as having taken place post spin bit change. Spencer, I'm going to learn from the mistakes of the people who came in front of me and ask to defer all questions to the end. I'm good with that. Okay, next slide, please. So there are a bunch of sparse traffic examples. Logging, for example, if you ran syslog, it would work like this. Some kinds of compute-intensive applications, DNS queries to a caching resolver, unidirectional streams in the case of like RTP being sent over this. I realize that's not V1. You would actually be measuring your ACK coalescence in sort of RTCP-like ways. And all of these then would show up with the previous pattern that we just discussed. The logging example itself may in fact be insensitive to round trip time because of the way it works. But in a lot of these other cases, the app response time can dominate the RTT. Note, by the way, that this is all about using this to measure round trip time latency, and all of these remain sensitive to loss, even if they're not latency sensitive. Next slide. Additional processing, I will note that there were people in the design team who didn't really think that this was additional because they're measurement guys, and from their perspective, this is the cost of doing business. But I point out that, I can see nods from other people who believe it's the cost of doing business, but I point out that it has to occur. You can reject samples that appear to have these characteristics pretty easily. You can just throw them out on simple heuristics. That didn't look like that was a tight exchange. I'm just not going to count this. If what you're trying to do is to figure out something like the mean round trip time on a particular path, but you're not actually looking at specific flows. So there are definitely cases where very, very light amount of work can get you additional information. You can also, instead of analyze the flow characteristics, you can characterize the flow to infer a traffic type and then conduct the analysis based on the inferred traffic type. This is a little bit more complex. Again, for the measurement guys, this is the cost of doing business, but what it turns out to mean, if you can easily determine from the flow characteristics that, yeah, this is almost certain to be RTCP-like ACK coalescence, then you can go ahead with your analysis if you've correctly characterized the flow. Note that there is a concern here that you then might decide, in order to help them correctly characterize the flow, you need to add other things to the wire visible parts of the exchange to help them characterize it. That is in fact straight out leaking that information, and nobody in the design team really proposed doing that in any specific way. But I throw it out there just because it's an obvious thing that would happen. Next slide, please. So, is this worth it? Next slide, please. Maybe. The design team did not come to consensus on this point. We would have loved to have come to consensus, but after a bit of back and forth, I cannot claim as its reader of consensus that it did so. We did seem to believe that the geolocation threat was negligible and no other threats were identified, but clearly this does provide some information to an observer, friendly or adversarial. We don't really know yet what the adversary would want to it, but they're clever little, and I have to restrict myself from characterizing them. But it is clear that the network managers would want rough estimation of the contribution of a leg of a path to latency, implicit measurement of congestion, and potentially some passive troubleshooting. There are other ways to get each of these, but if this were present, it would get used for some aspects of this. I'm so glad I asked you to hold them to the end. Really, I have done nothing clever today until that. Please, next one.
We can just, have everyone
And
sit
by the
down
way,
and go around
Brian
the
is
room.
already in line 3 times. I can see him cycling through the line. It's very funny. Next slide. Next steps, we recommend closing the design team. It didn't come to consensus on this. If you hand us other questions, we kind of suspect the same thing might happen. We think that the right thing at this point is to take the question of the working group. A full working group discussion of this is more appropriate than more discussion in the design team. We also believe that there was some output from the hackathon. I'm getting etsy-ketsy marks here
really.
from Brian.
I can summarize a little bit of that.
Okay. That might have helped us carry that forward. If there is other data that can come to the working group so that it's not just based on this, that would be wonderful. And we also probably should consider up-leveling the discussion to reconsider methods for delay and loss detection that aren't this. Last slide. This is the data that the group kind of used in this discussion. Please do review it before we start the working group discussion so that you don't kind of go back. And if you have other links you want to share with the group, those are obviously going to be great. We appreciate that. I will note that we asked the design team if we could make the discussion open to the working group post facto and just kind of share the discussion. But there was unfortunately an objection. And since I did not make that as an early condition, I unfortunately will not be able to share that. So let me just count here.
Can we ask people to be brief?
Yeah, there are already 10 people in line. So if you believe you might want to get in this line,
would it be more comfortable
before
if
they
we pass
close
the
it,
microphone around
I
the
suggest it's probably better for you to get in the line now and step out if you decide you don't need to.
And so to be clear,
come on.
we have 25 minutes and we have
John
more than
got
10
in line
people in queue.
without knowing why. Surely you should too.
Right.
No.
Okay. Just now, Brian. Seeing who's behind me in line. Hi, Brian Trammell. Would you like these in slide forward or slide reverse order?
They're moving the slides. You take them however you like.
Random slide order. Yeah, it's Max. Yeah. Right. Yeah. Okay. Priority. Okay. So
Briefly, please.
okay, you called me out here, so I'm going to start with this one on 8. We have a student who has implemented the latency spin bit in a fork of Mink. It does what it says on the tin. When you have like, you know, full demand, right? Like you have full traffic in at least one direction, you get a very, very, very good estimate of what the sender's estimate of the RTT would be, right? Like, so comparing the internal RTT estimate to what the spin bit signals, it works, right? With respect to the issue that you identified with ASCII art, you can go back to that if you want to. This is actually a relatively well-known problem in passive TCP measurement. There was actually, I forgot to bring this to the attention of the DT. There was a paper in ACM CCR
Brian,
about a year ago.
Brian, do you have something that you're disagreeing with
Yes.
Ted about?
Yes.
Okay. I'm going to ask the folks who are members of the design team to consider that if you don't have something that Ted hasn't covered, you know, we want to hear from the rest of the working group, and we have a lot of people. So please keep that in mind.
Can we go then to the thing that I disagree with? That would be on 6, I think. No. Yes, I also disagree with this. The maybe is incorrect. I think it's worth it. Can we go to 5? Yeah. So I think the concern about this leading to traffic analysis is a little bit overblown. Because again, this is a very well-known problem in passive round-trip time measurement, and everybody uses extremely simple heuristics, and nobody says, oh, well, I don't know what the RTT is, therefore I have to like actually figure out what type of traffic this is. I think that saying, okay, giving a latency signal to the path that is very easily heuristically rejectable with very simple heuristics is not a slippery slope toward other nastier things. I just think that's total BS. Yeah, okay, since I'm only up here to disagree, I will let other people speak. Thanks.
Mia Kulevin. So I'm not sure if it's a valid point to say we have a couple of use cases which are maybe even the important use case we look at the moment, and those use cases it doesn't work, and so we don't need it because this is a general purpose transport protocol. So there are use cases where it will work, and if you know that your traffic characteristics will not lead to useful values, you can even just set the bit to 0 always, and then say like, I'm not supporting it because I know it will not work. That makes your life easier. The other point is I'm a little bit afraid that we could always say we do this in a later version or whatever, but we will only figure out that we need this when the deployment of Quic is so high that we can do any measurements on TCP, on like competing TCP anymore on the traffic, and then it's so widely deployed that we don't have it, and then it might be too late, and then it might be really hard to get it in. While I think it might be much easier to just put the bit in, and if nobody uses it, nobody needs it, we can put it out at a later version.
So thank you for that comment, because it actually reveals something that was, I think, a very strong assumption among some of the people here, and that is that if it was in, it would be used all the time, because otherwise using it would be, in fact, a signal.
Yes, so my assumption is you would use it by default all the time, but I'm just saying that it is still possible to set it to 0.
Ronnie?
Ronnie Evan. I'm glad to hear Martin, Brian talk about disagreement about that, because I surprised reading that, because I mean this is similar to TCP basically. It's have the same. You want to measure the RTT in the middle between the upstream and the downstream, and it's done in TCP with all the things like you said. It can be delayed in the one side. The message will not be continuous. The ACK will come later. It's doing the same mechanism. The only difference here is that instead of the ACK, you get the spin bit that tells you that this is basically the return message. So today it's working and it's being used. And again, like I think that's important that it should be implemented as a mandatory feature in the first release in order to be able to analyze what's happening there.
Ian Sweat, Google. I had a high-level question: did people largely think this approach was sufficient, or and if if so or not? Like, were there things that different approaches people like better, or is that kind of like out of scope of the discussion?
So I think if we do take the next step seriously and up-level the discussion, then other mechanisms would come into play. And it's definitely true that one of the issues that many people in the design team were concerned about is capturing loss on the path, and this is very poor for that.
Okay. So, okay.
Daniel Kahn Gilmore. I think one of the things that so the discussion that was presented here, thank you for summarizing it. It doesn't mention that people may be forced by the networks, if this exposure is present, to basically emulate whatever the standard expected pattern is. Certainly, if we're talking about shipping V1 of Quic as HTTP only, there are certain traffic flows that will be expected, and if the network started measuring things on the basis of a spin bit like this, that will be what Quic looks like. Which means if you want to do anything other than HTTP in the future, then you may be forced by some networks that have decided this is the way that we measure traffic to emulate HTTP. Or the traffic patterns of HTTP, and I think that's a mistake if we put ourselves in that situation.
So thank you for raising this point. I don't think that there is consensus in the design team that this was a potential source of ossification. It was brought up, and probably I should have put on as discussed, but no consensus.
So we've been discussing this issue since.
Say your name.
Take it, Alex.
So, do you hear me now?
Yeah.
So we've been discussing this issue. We've been discussing this issue basically since the beginning of this working group. We had this discussion in Tokyo, in Paris, in Prague, and we always had the question come up: what do we really gain by that? There are people who claim that this will give us enormous benefits on the network, that they need this to make it work. But I haven't seen any numbers. I asked for the numbers a couple of times. Other people have asked for those numbers, but I've never seen anything. So those people who really want it, why don't you present us the numbers?
So I would appreciate it if you would review the links that are at the end of the presentation, because some of them actually do contain the numbers that you're looking for.
Oh, I'm not looking for the geolocation.
That's not all. Not all the links deal with that. So I would appreciate if you would review it, and then if you find lacunae, bring them back to the working group. Okay.
And I'm going to remind people not to interject from the audience if you're not at a mic, please.
Marcus, so yeah, there are a lot of links there where we show that's very useful. And I would also like to say that I think among the people who actually want to use this was quite a big consensus in the group that this is a sufficient mechanism.
So can I ask you a clarifying question? You meant a sufficient mechanism for latency, not for loss, right?
For latency, yes.
Thank you.
Gory Fairhurst. Thanks for the analysis. You looked just at the spin bit, and from what I understand, you say you didn't see the security threat which was discussed at the previous meeting.
We examined the geolocation threat in detail and decided it was not a significant new source of geolocation information because of the way the RTT is determinable from the handshake data and because of other sources of similar data.
Okay, I like the list of things you said it gives. Are we going to look at other mechanisms that provide more feedback and better RTT estimation? I mean, that might be enough to go with. I personally would go with that being mandatory at the moment. Are we looking at more?
Okay, why don't you just hand it to the person next to you rather than putting it back in? Thank you.
Thomas Nokia. To the question whether this is valuable, I think it is. Although it's a bit too weak as a signal, we would like to have more from a measurement perspective. But better this than nothing. And to the privacy problem, having read Brian's draft document a couple of times, I'm quite convinced that it's not a problem. And having worked with the CDN and the redirect routing and creating the MaxMine database, you have very, very precise information about where the endpoint is. So effectively, this wouldn't provide any additional, as you say, information. There are limitations, and the main limitation I see here is that the two endpoints can basically fake the information. There's no the game is such that the network doesn't can't rely really on the signal that comes from the endpoint, because the signal doesn't change anything on the state machines on the two endpoints. But if we can convince the endpoint to cooperate, is good. As I said, is better than nothing. And to the ossification problem, which I think DKG was mentioning, I don't see this because it's used in a different way. It's used passively. So I don't understand. If you can clarify this better.
So I'd like to pick up on something you said just to reinforce it to the group, and that's this. The way this measurement works when you're using TCP is you're taking information which is required for the state machines on the endpoints and examining it as it passes through the network in order to get this data. Falsifying the data going through the network requires falsifying the data you're sending to the state machine of the other endpoint. Because this is data which is consumed only by the path, altering this data at the endpoints, changing when you do the up and down bits in order to mask the data, does not require any change that influences the state machine of the other endpoint. Next.
Jesus Martin, Telefónica. Despite that the fact that additional processing is needed, as you very well said, we see this as a very useful tool to do troubleshooting, to perform a better management of the network. So we would like to see this included in version 1.
Thank you. Al Morton. I got up to respectfully disagree with my design team colleague. I don't believe that.
Al, can you speak up?
Oh, sorry. That's good now, right?
Yeah.
I don't believe that having insufficient traffic would be a forcing function for ossification. I don't think that the network providers would ask senders to send more traffic so that the measurements could take place.
That's not actually what he's saying. So possibly you could work with him offline to get a truer view of his point.
Okay.
Thank you.
Jana Iyengar. I was actually hoping that we would have some strong sense of. I want to echo what Martin said earlier. Martin Zeman said earlier about demonstrated need. It's not so much that we need to show numbers about exactly. You can't show numbers until you actually have this deployed or until you have it in use, or numbers are difficult. I understand that, but I was really hoping that we'd have a very clear understanding of what all this could be used for and what all this would enable. And that doesn't seem to be present at this level. Was this something that was discussed?
Yes, there was a good bit discussed. Some of it's actually in the links, but the primary things, if you go back, I think two. Go back. Sorry. No, one more forward. So each of the three things that are bullets here are things that members of the operational community asserted that they would be able to get from this, and that although there were other ways that they could get it, that if this were available, that they would actively use, passively use to get this information.
I'm sorry, what was the last bit he said? If they were not passively?
No, so I'm saying that there are other ways to get most of this information, but that if this were available, they would use this to get this information.
Understood. Okay, thank you. So the one thing I want to point out, and I don't know if it's coming out in that has come out, is that the network can in fact measure round trip time right now with quick packets. It can't do it continuously throughout the connection. It can be done on the first packets, it can be done on the handshake packets, and that's a pretty critical bit of information. That may not be all of it, but that's certainly a fair bit of information that's available. as it is in the network with quick
Yes,
packets.
and the design team pointed that out in rejecting the geolocation as new information, because you can clearly get round trip time from the handshake packet, and using a series of those, you could look for min RTT for a related set of IP addresses. So we definitely consider that and agree.
So so my concern remains that when we don't have, if we don't think that there's very strong demonstrated need to have this bit exposed, then it's just a bit exposed that doesn't get used. If it's something that might be useful, that to me is not strong enough. If it is in fact necessary and useful, that may be strong, but we need that.
Okay. I'm going to close the queues at this point. We've got 10 minutes left, and we have 6 people in queue, so please be brief.
Yeah, so first, an answer again, I think we looking at the links, and then you will see quite a lot of demonstrations where it's actually very useful and very critical for a lot of operations, especially troubleshooting and inter-domain troubleshooting, where you want to see differences in latency on different legs or different parts of the path. So say I'm measuring here, and I want to see if the trouble is in my domain or if it's in some domain outside. And that's very, then you would need to measure latency, you would need to measure it in the middle to be able to discern where the problem is. So that's a very important use case that many operators need this for. And there are, I think, 2 or 3 documents there describing how it's being used by different operators. And then I have another question. So if version 1 is focusing on HTTP, then many of these sort of corner cases might not apply. So we might need to rethink that as well, because these RTP and sparse traffic examples might not be so prevalent in the HTTP use case.
So I'll point out that this is a question about whether or not this is invariant, right? And so I think it falls into the discussion that we have to have whether we are trying to deliver HTTP first or not.
Ronnie, Evan, there was here a comment about that it's not part of the state machine, and that's why it may be falsified and be used differently. A lot of the monitoring today that are being done, for example, in IPPM, are not part of the state machine, and they are being used even though they're not part of the state machine. And for example, if you do it wrong, if the endpoint will do it wrong, it may hurt itself and not have a problem for the network, because the network by the end of that has to figure out if there are problems, and those problems are very typical, because if I'm a user and I'm watching something on Netflix and I see that it's not coming fast enough for me, I don't call Netflix, I call my service provider and complain, okay? And what they want to be assured is, because sometimes it's go through different service providers, they first need to verify where it is in the network that the problem happened, okay, if it's in their domain or in other domain. So that's why they take the RTT at different point in the ingress, in the egress, and figure out what's the RTTs to figure out where the delay is encountered. It may be in one of their devices, so they can figure out that there's something wrong with the device, the queue management in the device, the buffering, or whatever, and that's how it's being used. I mean, you have to understand that video doesn't go, and that's mostly important about video traffic. And video doesn't go just from the endpoint from the server to the endpoint just automatically with nothing in the middle. There are things in the middle that has to verify that it will flow and will flow optimized. And I think one of the if you talk about latency as one of the achievable things that we want to achieve here, so this is about latency basically, because you want to have the best latency. It's not only the connection establishment.
I'm sorry, we are time constrained here. Thank you.
Just hand it to the person behind you, and there's no need to.
Dan Drutza, AT&T.
Dan,
I'm a little
much louder, Dan.
Much louder. Okay. I'm a little bit disappointed that the design team didn't come with a conclusion, because we're back to square zero. In Prague, we discussed that there could potentially some threat surfaces, and I'm glad that the result is that there are no. It is needed for service providers, and it is in the charter that we need to provide at least the same level of manageability that,
No, that is not in the charter. It's that we consider it.
Okay. But in any case, I think it will be useful to be in the V1, and the working group to consider it.
Just pass it to the person behind you.
Thanks, Dan. Do you hear me? Yep. So last week on our network, we have to troubleshoot a drop of traffic Actually, we have the quick traffic which dropped from 100 to 30%. And in fact, to troubleshoot, we have to rely on the fallback on TCP because there was nothing available in the quick headers to troubleshoot. So the question is the fallback to TCP part of the invariance of Quic?
So I think that's not really a question for this, but I think it's an important question. You're asking
That's a
whether
very
or not
good
the
question,
fallback to
yeah.
TCP is an invariant or not.
And we discussed
if we-
fallback a while
if we
back.
have
Yeah.
TCP to troubleshoot Quic, we don't need spin bit.
That's an interesting point. We should put a pin in that. Yeah, let's get back there.
I'm tall, but I'm not that tall. Colin Perkins. So I'm very sensitive to the concerns of the operators here, and I think it's clear that they have real issues to solve. I think that the point which Ted made earlier, and I think Lars made perhaps over dinner last night, that since you can put stuff inside the encrypted parts of the packets that drives the protocol state, anything we put in the unencrypted part that the operators can see could be faked and could have no real relation on real data. That makes this difficult for the operators. Yeah. So we seem to be talking. We're going around in circles, but I think there's this issue that whatever we put in there may just be untrue, which perhaps changes the decisions slightly.
Yeah, that's also a good point.
Corey?
Gory, very quick question. We mentioned that there are other methods to get this fine-grained RTT at different places along the path. Can you explain what those were? Because I didn't see them.
Sorry, it wasn't necessarily the fine-grained RTT, but for example, understanding the contribution of latency for particular legs along the path. If you have the IPPM techniques that were in the draft for which Christian made the original reference, because you're actually
We're
tightly
going to use IPPM.
yeah, you're tightly matching the clocks of the various things, and then saying, "Hey, I saw this one," and move the up bit to down as I went through this. You actually get very, very strong information from that, but at a cost. And the cost is that you must now synchronize the clocks of these routers, and you must be active on 2 points in the path, adding the moving the bit up and taking it back down as you ingress and egress your network. But certainly, if you're willing to have that kind of measurement architecture in your network, you can measure your own network quite successfully without this.
Yeah, you can measure your own network using MPLS and et cetera as well. Yeah,
Right.
I get
So
that.
there's definitely other ways to get this information at different costs. And
Yeah,
let's
different
be
costs.
honest, the engineering trade-off here from the point of view of the operators isn't, is this the only possible way for me to get this, but is this a way that I can get it at scale conveniently for the traffic that is going to be crossing my network? And I think the question of what type of traffic is actually important there. And although I'm certainly willing to bow to the greater knowledge that you and Brian have about how much additional effort this looks like to measurement folks, I do believe that this is by far the most useful when you're not having to apply those secondary rejections and even lightweight heuristic algorithms to manage the flow analysis, because at that point it really just becomes a time series of data that's giving you RTT, which may reflect just network RTT or a combination of network and application RTT.
Thanks.
All right. So may I ask the chairs if they agree with the next steps, that this now moves into the working group for further discussion, or do you wish it to be deferred?
I think we need to talk and figure out a way forward. So let's
All right.
take it offline.
Then I believe I do not have an action item unless you give me one later. Let me know.
One sort of thought from the chair, since we had the session earlier in the session, we talked about the schedule and version 1 and the invariance, and that being a critical blocker for implementation. So I've heard different opinions about whether putting something like this, adding something like this to Quic was required for version 1 or not. I think it would be extremely urgent for the group to come to consensus on that part. And we have a minute. Brian, you can make your way to the microphone. I also have another question that's related, and that is, this was specifically about loss delay. Tangentially, loss detection was mentioned, and I'm wondering, so from the operator community, right, will you be happy with delay, or is loss the next thing? And will that also need to be part of the invariance or not? And we don't necessarily have to answer this.
Yeah,
we can't have this discussion now.
So,
But I would
just
like
wanted to point out very quickly that you have a third option here, which is to reserve this so that it is not consumed in version 1, rather than
Yes,
decided for version.
That was so the opinions I heard was either because we're doing greasing, we're going to have bits that we can use for this later. But I think Mirja specifically made the point that she would like to have this be part of version 1 because the traffic is going to be so large that by the time you have the problem, you don't have TCP anymore.
So
Brian, and then I think we really do have to break. Go.
So I actually came up here to say something very much like that. I tend to agree with Mirja that if it's just a greased signal that turns into a non-greased signal, then it's not clear if it's useful. But I will point out that the running RTT of the spin bit, as long as the handshake RTT is still available, the running RTT of the spin bit happens after you have a cryptographic connection established. So it's well outside the invariance, right? So you still have the problem with it possibly being greased and then not useful, but you could actually, if you really wanted to, you could put it just on short packets, for example. I mean, there are, so I think that this is something that if we absolutely have to, we can defer it as long as we know that it's a thing that we're deferring.
This is not by any means the last time we're going to talk about this. We're out of time today. So we're meeting again tomorrow, and I suppose if we have time and something useful to discuss, we can maybe continue that.
I would specifically sort of for these questions. So the questions about timing. So from the chair's perspective, right, we need to know whether this discussion blocks version 1 or not. So opinions on that, please send them to the list. Do it right now while you're waiting to go to the social. Do it on the bus and do it in the room tonight. And if you're all very good and keep the schedule tomorrow, we do have a few minutes at the end of tomorrow's session to maybe have a summary of some people's thoughts on this. Thank you.
Thank you all.